Okay, so today we're going to look at solving and graphing radical equations. We have looked at both of those already individually, so we're just really looking at the connection piece, as we have done with other functions. What's the relationship between solving and graphing? So here on the first example, we're asked to solve first algebraically, and there were three steps that we looked at whenever we solved radicals. The first one was to isolate the radical by itself, and it already is isolated on the left-hand side. The second step was to get rid of that radical by, in this case, squaring both sides. We get x plus 2 is x squared. And to solve, and if we have a quadratic, we solve by making one side of that equation equal to 0. So here I'm going to subtract x and subtract 2 to make the left side equal to 0. And when I do that, I end up with x squared minus x minus 2. And then typically you can solve a quadratic by factoring. So here we're looking for two numbers whose product is -2 and whose sum is -1. Does that work out? -2 and +1. And if the leading coefficient's 1, we can take that shortcut and just get to the factorization. So x minus 2 times x plus 1 is what this factors to. And then lastly, we can get our answer. So here, this is going to be x minus 2, 0. So x is 2. And x plus 1 is 0. So x is -1. So we get two answers. But remember that third step. When you're solving with roots, often you get these answers, but they really don't work. And we call them what? Extraneous solutions, right? And so I just need to check, make sure none of these are extraneous, or if they are, we got to get rid of them. So when we check this, if x is 2, we get the square root of 2 plus 2, and then say that's equal to 2. Is that true? So we get to keep that one. And then if you try x equals -1, you get the square root of -1 plus 2 equals -1. And I already see an issue with that. You guys see an issue with that? If you take a square root, you cannot get a negative answer. And so this cannot happen, false, okay? And so we got to throw out that second one. So we have one answer, that x equals 2, solving algebraically. Now on the right-hand side, it asks us to accurately graph the system of equations which is from the algebraic equation in part A. How's looking at f of x and g of x, how is that related to our equation in part A? What's the relationship there? F of x is what? It's the left side of the equation, right? That's the left side's f of x and the right side is g of x, right? And if we graph them, how's that going to relate to what we got over here, x equals 2? What are we going to see in our graph at x equals 2? What's that, Xavier? They should cross at that point, right? Okay, or intersect at that point. So let's check this out. So g of x equals x, that's probably the easiest one to graph. That's a line with a y-intercept of 0 and a slope of 1. Because there's a 1 in front of that x, and there's a 0 after that x, right? And so goes through 0, 0, and then the slope up 1, right 1. You just get this, cuts the first quadrant and the third quadrant in half. And I'm going to label that g of x. Okay. And then the f of x equals the square root of x plus 2. We have our starting point. We have a sense of what that looks like, right? It's kind of a half of a sideways parabola. And that plus 2 moves us to the left 2 from 0, 0 to give us a starting point. And then we can use a table of values to find some more. So x and f of x. What would be a good value to plug in for x to get something else? -1, I heard, and 2 is another one. So I'll start with -1. We get square root of -1 plus 2, which is square root of 1, or 1. So -1, 1. And then we heard 2, because when you plug that in, you get the square root of 4, which is 2. So 2, 2. And we see that f of g is equal to f of x is equal to g of x at x equals 2, because in our graph, that's where they both cross, at x equals 2. So solving algebraically, solving graphically. Okay, there is that relationship there. So I want you to try that on the next one. Same kind of thing. Solve algebraically first, going through those 3 steps, and then solve graphically. And see, make sure both of them have the same answer. All right, so on the left side, solving algebraically, we have negative square root of x plus 1 is equal to x plus 1. And when we square both sides, we can leave that negative there in front of the square root, but when we square it, what happens to that negative? It goes away. And so we get a positive, just x plus 1, equals x plus 1 times x plus 1. Did anybody think of just dividing both sides by x plus 1? So let's distribute it out though, but we could divide as long as x is not -1. We don't know. X could be -1, right? So let's distribute though. So you get x plus 1 is x squared plus x plus 1. X plus 1 is x squared plus 2x plus 1. And then we make the left side equal to 0 by subtracting x and subtracting 1. And when we do that, we end up with x squared plus x. Right? You guys get that far? Okay. Once you're there, different kind of factoring here. Factor out the GCF. Both terms have an x, so factor out the x. So you get 0 equals x times x plus 1. And so that x is a factor. We usually don't put parentheses around it, but it is a factor. So now we could set each factor equal to 0. We get x equals 0 and x plus 1 equals 0, which means x is -1. So 2 answers. Just need to check to see if we can keep them both. Okay, so if we try 0, we end up with negative square root of 0 plus 1 is equal to 0 plus 1. And so that's negative root 1 is 1, or -1 equals 1. And that's not true. So we got to throw out the 0. And then we try the x equals -1. We get the negative square root of -1 plus 1 is -1 plus 1, or negative square root of 0 is equal to 0. Is that true or false? That's true. So we can keep the x equals -1. So then we get to part B. We want to accurately graph the system of equations. And I'll start with g of x. It's a line with a y-intercept at 1 and a slope of 1. So 1 here, and I go up 1, right 1, or down 1, left 1. And that is g of x. And then our f of x. We'll translate left 1 unit from 0, 0, which is at the same point on that line. Okay. And then let's get a couple other points just to get a sketch of this graph, because it does say to accurately graph this thing. So x and f of x, we need a couple more points. Let's try 0. That gives us -1 for an answer. So 0, -1. And what would another good x value be? 3. So -3 plus 1, square root of 3 plus 1 is negative square root of 4, or -2. So at 3, -2. So this thing is moving down and to the right, like that. Okay. And so both of them intersect at x equals -1 from my graph. And if I check over here, x equals -1 is also a solution. Also, it gives some reason for why we should throw out x equals 0. Because these graphs are not crossing when x is 0, right? They're only crossing one time. Is it possible to have two graphs that never cross? To have a line and a square root function that will never cross? Sure. If we had a line that looked like this and a square root function that looked like this, and then we could actually find out what those equations are algebraically, put those together, and when you solve them, you get two answers. If you check them both, they both wouldn't work, right? Is it possible to get two that would cross 2 times? A line and a square root function that would cross 2 times? If you have a square root function that looks something like this, and a line that looks kind of goes through like that, you could. And so you can get two answers that would work. So these two examples, we only had one that would work out of the two, but there's other possibilities out there. So that's why it's always important to check these things with square root functions. Okay, the last part here is just practice solving, not only with square root functions, but also cube root functions are mixed in here as well. Okay, and so you guys have some experience with this already. So I'm going to give you guys some time to try them out, and then I'll call in some of you and ask you what you did and how you got it. Okay, go ahead and try these. Okay, Sydney, how'd you start number 1 or the first one? When you're solving, do the adding and subtracting first, and then multiplying and dividing first. It's kind of the opposite of the order of operations when you're undoing it. Okay. Add 1 to both sides. So you go 1/4 square root x plus 11 equals 2. And then how do you get rid of the 1/4? Divide by 1/4. It works. It's just weird to divide by a fraction, right? You can, but it's weird, right? You'd write it like this: you divide by 1/4, divide by 1/4, and it looks complicated. So instead of dividing by 1/4, you can multiply by the reciprocal of 1/4, which would be multiplied by 4, and that you get the same result. And it's easier to write and think about. And so I'm going to multiply both sides by 4. And so what happens here, I get 4/4, which is 1, and all we have is that square root of x plus 11, and we end up with 8 over here. So that's step 1. That means we isolate the radical, get it by itself, and then we get rid of the radical. How do we do that, Sydney? What do we do next? Good. Square both sides. Get x plus 11 is 64. Subtract 11 from 64 to get 53. That's our answer. And then just don't forget to check, make sure it worked out. We check that. 1/4 root 53 plus 11 minus 1. Is that really equal to 1? We just kind of work through this. You finally get to 2 minus 1 equals 1, which is true. We get to keep it. Done. Okay, so then the next one is a cube root function. It kind of works the same way. Kale, what'd you do first on this one? Subtract 4. You get 10, and then divide by 5. Okay. Okay, so at this point, we want to get rid of the cube root. So you cube both sides. When you cube the left side, you get x minus 1. What do you get when you cube the right side? And then you add 1, right? You get 9. Okay. And you check it just like we checked the other, just to make sure it worked out. So 5 times the cube root of 9 minus 1 plus 4, is that really 14? Bless you. And it is. We get 14 equals 14, which is true, so we keep our x equals 9. The next one has a square root on each side. Okay, and Jake, how'd you do this one? Did you get this far? Okay. What'd you do to start? Okay. Yeah, typically we say get the square root by itself, but if you do that, you're going to create fractions, right? And so I'd say that's the only exception. If it's gonna make it uglier, don't do it, right? And just here, probably the best thing to do is to square both sides as is. Just be careful how you do that. And so when you squared both sides, Jake, what did you get? Good, and that's the way to do it. And at that point, after you get that far, you want to distribute the 9 on the left-hand side and the 16 to the 3, okay? So you get 45x plus 1, or plus 9, equals 48x. Subtract 45x from both sides, and then divide by 3. We get x is 3, and so we just need to make sure that works out for us. So when we check this, check it before we squared both sides, we get 3 times 5 times 3 plus 1 is equal to 4 times root 3 times 3. And keep working through that. You get 3 times 4 is 4 times 3 is true. So we keep it. Okay. Good. Okay, then we have 2 variables in the next problem. One's underneath the square root, one is not. Right? Lauren, how'd you do that one? Did you get that far? Didn't get that far yet? You want to try it or no? Up to you. So you wanna get rid of the radical, but the way we get rid of it is get it by itself. So you do want to subtract 2x. So I would subtract 2x so that we can get rid of the radical. So let's subtract the 2x. And I'll do negative 2x plus 3. Okay. So we're trying to get rid of that radical. That's our focus. We're going to have to square both sides. We're getting it to a place where it's easier to square both sides. Because it's pretty ugly if we square both sides before we subtract that 2x. Now, if I divide by 5, I create fractions, right, that I can't reduce. So probably leave the 5 there. The only other thing that you might want to change before you square both sides, it's up to you, is you can multiply everything by -1 and get a positive 5x, 5 root x, is positive 2x minus 3. You may be more comfortable with that. It's up to you. Okay. So then I would square both sides at this stage and get 25 times x. On the right side, you're going to have to rewrite 2x minus 3 times 2x minus 3 and work through that. So distribute all 4 products. Okay. And then get it to a place where we could try to factor a quadratic that's equal to 0. And so I'm going to combine like terms. And then subtract 25x. So then we got to try to factor this thing. Remember how to factor stuff like this? If there's a number in front of x squared, we have to look for two numbers whose product is 4 times 9, the first times the last, and whose sum is -37. What are they? -36, -1. And then we can't jump to the factorization yet because of that 4 out in front. Instead we split from 3 terms to 4 terms. So we go 4x squared minus 36x minus 1x plus 9. So that we can, once you have those 4 terms, you could factor it by grouping. And so you group the left-hand side and you factor out the 4x. And on the right-hand side, what can we factor out? Just a -1. And both terms now is split. Now we have 2 terms. Both have a factor of x minus 9, so we could factor the x minus 9 out. And we're left with 4x minus 1. Finally, it's factored. So we can solve now. X equals 9. And x equals 1/4. Okay, so this is a longer one, right? And we got to check. Can we keep them both? We got to get rid of them both? We don't know until we check. And yeah, one's a fraction too. We got to check with a fraction. Yuck, right? So let's try the fraction first. See what that looks like. X is 1/4. We got 5 times the square root of 1/4 is equal to 2 times 1/4 minus 3. Well, square root of 1/4 is what? 1/2, because you take the square root of 1 and the square root of 4. Okay. 2 times 1/4 is 2/4 minus 3. What can you tell me without even doing this? When you go 2/4 minus 3, is it going to be positive or negative? So the right side is going to be negative. How about the left side? It's going to be positive. And so can a positive number equal a negative number? So you know this is false. That's enough to throw out the 1/4. Okay. And then if x is 9, five times 3, is that the same thing as 18 minus 3? Yes. So, all right, the next one. Here we got to plug in f of x, the square root of 8, x plus 8 for f of x. And we get 3 times the square root of x plus 8 plus 2 is 17. Solving for the square root, we subtract 2 first, and then divide by 3. And then we can square both sides. You get x plus 8 is 25. Subtract 8 from both sides, so 25 minus 8, 17 as an answer. And then just check that. And you see that it works out. And our last one here, f of g of x. Well, we're going to plug in g of x into f, and that's going to be the square root of x minus 1 is equal to g of x, so that's x minus 1 plus 1. Now the x minus 1 plus 1 we can add together and get the square root of x minus 1 is equal to x. Square both sides. Get x minus 1 equals x squared. Set one side equal to 0, so I'm going to subtract x and add 1. And then try to factor. We're looking for two numbers whose product is 1 and whose sum is negative 1. You try and try and try, and it just doesn't work out. So when factoring doesn't work for a quadratic, you use that quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, a is 1. That's the number in front of x squared. B is negative 1, and c is positive 1. So we plug these in. Negative, negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 all over 2 times 1. Simplify this. 1 plus or minus square root of 1 minus 4 over 2. And keep going. Get 1 plus or minus root negative 3 over 2, which is 1 plus or minus I root 3 over 2. So we have imaginary solutions, but it depends. Are we looking for imaginary or real? If we look back to the instructions here, what does it say? Solve the following for x. Check for extraneous solutions. Here, we're just going to end with this answer. It doesn't say if it should be imaginary or not.